Continuing in topic 4 now of chapter 2, applications of linear equations. Here we will use English and then convert it to algebra and solve some problems. These are the objectives. If you want to pause to look them over, notice here we have the standard form of the linear equation. And by the way, when we say linear, our unknown, the x, is only to the first power. Now, there is a protocol that I believe we mentioned before where you are to reread, assign a variable, sometimes a diagram may help or a chart, then convert that into an algebraic equation, solve it, and then does the answer seem reasonable? And are you answering the question they're asking? So let's go on to this first one here as we look at it. If a number is decreased by 36, so they're using the letter n for the number. If a number is decreased by 36, and the results, this translates to an equal sign, is 76 less than twice the number. So twice the number, and then less 76. So again, they're outlining it here as we use, in essence, textbook material to go over it. And then once the equation is solved, again, let's solve this one here. We're going to transpose this n to this side, just becomes a regular n. And then we're going to transpose this to this side, where it becomes a positive 76, and the difference is 40. So our answer, as they show here, is 40. So this was sort of an easy one to start. They're giving us the answers, of course, down here, but we want just to start from scratch. 3 times, this is part of it, the sum of a number and 5. Well, a number and 5. Now, to make that a sum, we have to put it in parentheses. And they're saying 3 times that is equal to, that's pretty straightforward, twice the number plus 5. And they're laying it out for us. So let's solve this one too. So this is 3n plus 15 equals 2n plus 5. We're getting rid of our parentheses. I'm going to transpose the 2n to this side, where it becomes a negative 2n. So that leaves me with just a plain n. I'm going to transpose the positive 15 to this side, where it becomes a negative 15, and 5 gives us a negative 10. And there's our answer. Now, I've chosen to use the n here. Often the x is what is the unknown. But if they tell you to use a certain letter, that's the letter you have to use. And again, be sure you're including the example number. This is 3. Joe wants to budget 2/5 of his monthly income for rent. He found that an apartment he likes is $800 a month. What monthly income does he need to be able to afford this apartment? Well, what will be the amount he's going to need? Well, he's going to need X. Now, this is going to be something that's going to be his rent that we know is $800. Now we know x doesn't equal 800, but he says 2/5 of this x is going to be 800. So we put the 2/5 there. Now, 2/5 of his total income is equal to 800. There's our equation. So what would the strategy be to solve? Well, we're going to use the reciprocal, 5/2 that we've used before, and 5/2. Here, these all cancel out and become a 1x. Now, 2 will go into 800 400 times. Cancel that out. And then 5 times 400 is 2,000. And that seems reasonable. Again, this is example 4. Student bought a calculator and a textbook for a total of this much. The textbook costs this much more than the calculator. He challenged a friend to calculate the cost of each. Well, how much did the calculator cost? Well, we don't know. Let's call that X. How much did the textbook cost? Well, we knew he spent as much as he did on the calculator plus 2050 more. So our equation would be the sum of this and that is equal to the total. So x plus 2050. Again, this is the calculator. This is the textbook. And the total was 280. Now, we're going to group like terms. We're going to get 2x. We're going to subtract or transpose the 2050 to both sides. And we get $180.30. We're now going to divide both sides by 2. And that'll give us the cost of the calculator first. Then we're going to add the 2050 to the cost of the calculator and get the textbook. And we can see that worked out here down below. Divide both sides by 2. We can use the work, that's fine. And that gives us 90.15. Then we're going to add the 20 to it, and we get the cost of the textbook. Now you're going to need to write this out. I'm taking a few little shortcuts here. Now for example 5, and we're going to use this as a model of any kind of example you might have on Certify and Practice. Here, brother and sister leave, so they suggest a diagram here. And they're going in opposite directions. And we see that one is traveling 50 miles per hour, and the other is traveling 65 miles per hour. And they're wondering, how long will it take for them to be 460 miles apart? Well, for this, we're going to use the distance formula. Distance equals rate times time. We worked with that in the last section a little. Now we have the distance here. We know this is a rate. Now we just have to times it by the time. And we know the time is going to be the same for both drivers. Just the rate of speed is different. So this rate times time is distance. So this is a portion of the distance. Rate times time is distance. This is the other portion. So if we add the two distances, that's going to equal the total here. and that will be 50t plus 65t. This is going to be 115t equals 460. So if you divide both sides by 115 now, we get t equals 4 hours. All right, now let's take a look to see what the book has done here. Making a nice little chart, okay. And it's set up very similar, and there it is. Does that make sense? If you multiply this by 4, that's 200, and multiply this by 4, that's 260, and that adds up to 460. So we did a good job, and they are checking it as well here. Again, you want a protocol. Now again, I have some background experience already in this. You might have some that you might remember from high school, but you want a protocol to do it. So read the question, reread it, develop a strategy. If you've already done one similar, use that as a model. Make it. Again, this is number 6. Here a motorist averages 45 miles an hour for the first part of the trip, 54 miles for the last part of the trip. If the total trip took this many hours and was this long, what was the time for each part of the trip? Now, for this, I want you to follow along carefully with what I'm going to show you, because this can be used for any time you have a problem similar to this. Now, this box is going to stand for 6 hours. We want to divide this 6 hours into 2 parts. And this is the beauty of algebra. So I draw like a little line. Now, do I know how much each part is? No. But I'm going to say let this first part here be t hours. We don't know how much that is. Now, if we subtract these t hours from the 6, that would be the other part. So let's show that. 6 minus t. Now notice, if we add these 2 up, they add up to 6. But using algebra, we've divided the 6 into 2 parts that we don't know. Now, they want to know how much time for each part. So I'm going to say 45 times t, that's rate times time, which is a portion of those 6 hours, plus 54. Now, what was the other part of the time that we don't know? Well, it's 6 minus t, and that total trip was the distance of 303. So now we have rate times time, rate times the other time, and that equals the total distance. And that's what they're showing down here. So in solving it, let's solve this one too. 45t plus, and we have to do this multiplication, and since there I have it done here, I can use their calculations too. I won't have to get my calculator out. That's going to be 324 minus 54t equals 303. Now, when I subtract the 324 from both sides, I get here a negative 21. And when I add up my 45t and my negative 54t, I get a negative 9t. So I divide both sides by a negative 9. Here you have to be careful of the sides. And you're going to end up with a positive when I simplify this t, and I can take 3 out of each one, so this is 7/3, which is what they have here. Now, what we have to do is subtract the 7/3 from 6 hours. And when we do that, we get the second part of the trip was 11/3. Now, if you want to convert that to hours here, because this is like a little fraction, it is hours, but 3 goes into 7 twice and 1/3 left over, and 3 goes into 11 3 times and 2/3 left over. So there would be the time in hours. Again, this should be reasonable, but this is what they want. Now, for a question like this, you have to be careful what they're asking. They were asking for time. But how about if they said how long or what distance did you go at this rate? What distance did you go at the other rate? You would have to take this time and multiply it by the rate, and that would give you the miles. So this is what they've worked out here. But again, they're not asking for that. You have to be careful what they're asking for. Now, I do give partial credit on many of these kinds of questions. If you have the correct equation, made an error somewhere. All right, let's go on. Now, in this next example, we have 2 more to go, this one and one other. We're looking for the average or the mean. And how is that done? Well, here we have 1, 2, 3, 4 grades on 4 exams in an English class. What score would you need on the 5th exam to end up with an average of 90? Well, I could write it out, but let's just copy what is here. So you're going to put the 4 scores plus the unknown score, use a grouping symbol indicating this is a sum now, that to find the average you're going to divide by 5 because there are 5 items, and that equals 90. Now, the first thing you want to do is, what I would do is I'd just multiply both sides by 5 here. And that's what they're doing. And they're getting 450. And then I've gotten rid of the 5s already here. And they're taking a little while to do that. When you add these 4 scores up, you get 347 plus x. And now the division bar is gone. So you're going to subtract 347 from both sides. And when you do that, you get x is 103. Now, one of the things is, would that person actually be able to maintain an average of 90? Well, normally you don't get 103 on a test score. Sometimes you might have extra credit, but let's say normally no. So this person wouldn't be able to maintain an average of 90. And that is the answer in specifics of what they would need on that 5th test to earn a 90. And this is the protocol to do it. Now, again, hopefully you're pausing, reading the examples carefully, and then perhaps even looking over the strategies mentioned here as we look at the textbook. But this is one that's very typical of what we have. A jeweler paid this much for a ring. He also wants to give the person a 30% discount when they come to the store, and he's like offering them a discount of 30% of the price he has in the window or in the case. But he also wants to make a profit of 20% of his cost. Okay, so what should he pay, or what should the selling price be for that ring? Now, this model that was set up here is very important. Here we have the selling price, which we don't know. We're going to call the selling price X. Now, if you subtract the cost, which we know is $350, then you're going to have a profit. Now, the profit we know is going to be 20% of his original cost, which was $350. But you might say, well, wait a minute, there's something wrong with this equation, because he's not going to actually sell it for X. He's going to give that person a 30% discount. So he's actually going to sell this for 70% of that original sales price. Okay, this includes everything, and that's what they're showing down here. And here's where you take X minus 30 to get the 70%, or 0.70. Now they do all the work, and I'll use that too to help us speed things up a little bit. I wanted you to see where it came from. And there it is. So copy this down. 70% of the sales price minus his costs, and then 20% of $350 is $70. So divide both sides by 0.70, and you get X is $600. That would be the sales price in the window. But just think, when you go in, they're going to give you 30% off. Remember, people have to make a profit on things, and this is often the kinds of things you would expect to go on in the business world. Okay, we'll wrap this up.